these problems are just a little bit trickier only because we now have both negative bases and negative exponents, and some of our bases are in fact fractions. So we have to remember more of our properties of exponents. Let's dive into this first one. Once again, that negative 32, it's not in the brackets I just drew, so let's get rid of those. That means that we simply have a negative 1 multiplied by 32 raised to this exponent. It's a three-piece exponent. It's got a numerator, which tells me to take 32 and raise it to the power of 4, or multiply 32 by itself 4 times. It has a denominator of 5, which says take the fifth root of 32. And it's a negative exponent, which means take the reciprocal. But not of 4/5. It means take the reciprocal of the base. It means pick up that 32 and drop it in the denominator. I'll do that step first. That gives us 1 over 32 to the power of 4 over 5. Now let's wrangle that denominator. Or rather, the denominator of the exponent. It tells me to take the fifth root of 32. The order is 5. All right, and that needs to be raised to the power of 4. Again, you could raise 32 to the power of 4 first, but gives us an awfully large number. So that's going to be equal to 1 over the fifth root of 32, which is 2, and then 2 raised to the power of 4. So finally, we have negative 1 over 16. What about this next one? 9 over 16 to the power of 1/2. Remember that if I've got products or quotients like this in the brackets and they're all raised to that 1/2, it literally means I have to take everything in the numerator and everything in the denominator and raise it to 1 over 2. All right, so that means 9 to the 1/2 and 16 to the 1/2. Raising anything to the 1/2 tells me to take the square root. The 2 is the order of the radical. So this is really the square root of 9 over the square root of 16. The square root of 9 is 3, and the square root of 16 is 4. The next question I'm probably going to try here is the one right below it. It's so similar. The only difference is the negative in the exponent of this second question. You can probably go right ahead and write the answer. We know what 9 over 16 to the power of positive 1/2 is, so how does having a negative exponent change the outcome? Remember that both the 9 and the 16 are raised to that negative exponent. So the 9 moves to the denominator, the 16 moves to the numerator. In other words, we take the reciprocal of the fraction and we get 16 over 9, and that's still raised to the 1/2, but the 1/2 is now positive. Of course, the numerator and the denominator are both raised to the power of 1/2. So we get 16 to the 1/2 divided by 9 to the 1/2. 16 to the power of 1/2 is the square root of 16. And in the denominator, we have the square root of 9. So our final answer is 4 over 3. One more to go. One thing I didn't look at necessarily with these first two questions is whether or not I can simplify inside the brackets before carrying on. I do want to check this every time. In this instance, we have 125 over 64. We can't simplify any further. So we're going to go right ahead and raise everything to the power of 2/3. So 125 is raised to the 2/3 and 64. What does the 3 tell us in each case? It tells us to take the cubed root. So we'll take the cubed root of 125 and the cubed root of 64. I haven't dealt with the 2 yet. The 2 says raise everything to the power of 2, so I could drop brackets around what I've just written and raise it to the power of 2, or I can do so individually. We'll have to square the outcome. The cubed root of 125 is 5, so we're left with 5 squared in the numerator. The cubed root of 64 is 4, so we're left with 4 squared in the denominator. 5 squared is 25, 4 squared is 16. If we couldn't simplify 125 over 64, we still can't simplify 25 over 16, but it's not a bad idea to have a quick look. And in fact, we are done.